Hello, guys. Good evening. Hope everyone is doing good today. So, today we'll be starting or continuing our fourth part of our data engineering series. I'm glad there was an amazing response from all of you, and I'm very happy to further continue this so that it is beneficial to all aspiring data engineers out there. So, before we jump to our video, so who are we? We are Data Valley, the fastest growing edtech company of 2025. And this video is brought to you by Franklin. And I have almost 3+ years of experience as a data engineer. And I feel glad I could bring up these kind of knowledgeable contents to you because I've been through this. There are many people who have been through this. So this is a collection of questions, or collection of expected questions or sample questions that might be asked in an interview. So if you would be benefited out of this, I'm super glad about it. So make sure you pay your attention and you learn as much as possible. And you all know the routine that we have to do about it. So grab your coffee, come sit relaxed, sit for like an hour, and enjoy as much as possible. And while you enjoy, make sure you stay focused. If you have any questions or doubts, please do drop it in the comment section, and I'll make sure that I'll clarify it in the upcoming videos. So without further delay, here we go. This is our data engineering series 4. So what are we covering today? So in today's video, these are our contents. So we are planning to cover few SQL questions, and then we'll be going to data modeling, then continuing to big data tools, ETL pipelines, and then we will end with few cloud technology questions. All right, so this is our agenda for today, and here we go to our first part, the SQL. So how can you detect and remove duplicates in SQL? So as a data engineer, yes, you will be constructing a data pipeline. And while you are constructing these pipelines, it is the responsibility of a data engineer to ensure the accuracy of a data, the completeness of a data. And as a data engineer, you'll be trying to enrich as much as possible. So what do I mean by enriching the data? Enriching the data includes, but not limited to, removing null values, remove the missing values, or using some predefined values as a replacement for those null values or missing values. And then you'll be trying to handle the outliers. You'll be trying to handle all the data that is duplicated. So there is a lot of data quality measures a data engineer will be handling while trying to handle all these data pipelines. So of that, one of the main important thing is, how do you detect and remove the duplicates in a SQL? So this is a crucial part in a data pipeline where you will be ensuring that there is no duplicates in the data flow. Okay, so how do you do it? First, I'll try to explain the code, then we will try to see that in a practical implementation in a MySQL workbench. So before doing that, the first step is try to understand the question. How do you detect and then remove the duplicates in SQL? So your first part is detection, and then your second part is removing. So how do you detect the duplicates first? Okay, for example, let's say I have a table named employees, and what I'm trying to do is I have few columns named name, department. All right, so these are the columns I'm choosing out of my table employees. And now here is what I'm trying to do. I'm grouping it by name and department. And why am I doing it? In most cases, a name will be an unique ID. But there are chances that though the name might be same, but they could be of a different department. So that makes a difference, right? Let's say there's a employee named Franklin. So Franklin can be part of an admin department, and there can be another Franklin who is of an IT department, and there could be another Franklin who is part of an HR department. So what we are doing here is we are grouping it by two values, or the two column values, that is name and then the department. Okay, so if we are using department, then what we get to do, we are grouping it first by name, yes, and then as a subset we are also grouping it by department. So what happens, we are trying to detect the duplicates. So as long as the name and the department are same, you're going to get a count that is more than one, right? So what does the count function do here? So count function counts, right? Counts the whatever, the value or whatever groupings that you have set, whatever the aggregations that you have set. So in here we are grouping it by name and department. Let's say there are two Franklins for different department, IT and an admin. So Franklin of department IT, the count is going to be one, and Franklin of department HR is going to be one, right? But for instance, let's say that Franklin, and he's from the same department, IT department, Franklin IT. In that case, you're grouping it by name and department, and hence it is going to show as a flag count as 2, right? Because same name and same department, that is getting repeated twice. So what we are doing here, so how are we detecting it here? So what we are doing, we are using having here. If there is anyone who remembers why do we use having instead of where, because where is not used for an aggregate value, and because we are aggregating here we are using having, right? Because we are counting, so that's an aggregate function. So because we are trying to use a value or filter the value from an aggregate, so we are using having here. So for the count that is above 1, what are we trying to tell? Display those to me. So that's how you detect the duplicates. The next step is, okay, you have detected the duplicates. So how are you planning to remove the duplicates? Okay, this is where the CTEs come into play. What is a CTE? It's a common table expression. So what happens in a common table expression? You create a temporary table. All right. So what's happening here? I'm trying to create a temporary table called ranked, right? So with is my keyword and ranked is my alias. It can be anything, and I'm just naming it as ranked. And as is another keyword, part of the CTE syntax. So with ranked as, and here is my temporary table coming up. So what I'm doing here, in here, I'm trying to select the employee ID, then the name, the department, and I'm using a window function over here. So we will try to understand why I'm using a window function over there. Okay. So what's happening here is, okay, let me minimize it. Okay. So this is our temporary table name, that is ranked, right? With ranked as is our temporary table name. And then what I'm doing here, I'm writing a block of code within the CT. So what does it stand for? It says that select employee ID, select a name, and select the department. Okay, easy. And then what I'm doing, I'm using a window function, which is a row number function. So what does a row number function do? A row number function assigns a row number to each of the row, irrelevant of the order, or irrelevant of any kind of order. Basically it could be ascending or descending, or it could be based on alphabetical or numerical, it doesn't matter. But row number function allots a number to each of the row. So I'm using a window function row function over partition by name. So I've already said you, isn't it? So when you use a simple code, group by is fine. And when you try to use it within a window function, you don't want your rows to be collapsed, right? You don't want your rows to be, you know, combined or merged, right? But instead, window function sets a window frame, right? So you use partition by here so that your rows doesn't get collapsed. So partition by name and then department. So I'm using partition by for two column values, that is name and department. Then I'm ordering it by employee ID, and I'm giving an alias for my row number as RN. Okay, so as is a keyword here. So you use as to assign an alias. So I'm using RN, signifying in other terms row number from the employees table. All right. So for the table ranked, I've I've taken some values from my employees table. And then now what I'm doing is, yes, I've selected the name, I've selected the employee ID, I've selected the department from employees table, and I've assigned a row number for each of these rows that was taken out from the employees table. And here is the crucial step. What I'm trying to do here is delete from employees. So to my table employees, I'm trying to delete this. Okay, don't confuse this with the CTE table. Okay, because CTE tables alias is ranked, it is not employees. Okay, a ranked table is taking values from the employees table. That's what the code block does. And now to our original table, that is employees table. What I'm trying to do here, where employee ID in. So I'm trying to find if there is any employee ID in particular subquery. So what is my subquery? It is simple. Select employee ID from ranked where row number greater than 1. So I'm trying to choose an employee ID. Okay, from ranked. What do I mean by ranked? So ranked is my common table expression table, right? So this is the name for this particular table that we have created. So from that, what I'm trying to do, I'm using where filter, and I'm checking if there is any row number greater than 1. Okay, in that case, what's going to happen, we are going to delete it. Okay, so let's see that in the code implementation for a better understanding. Herein I have got my MySQL workbench, and this is our data engineering series 4. So let me create a new database. Let's create a database called data engineering. Let's use the database. So we use data engineering. So how are we going to detect and remove duplicate? So first, let's see if we have got the table. We don't have the employees table because we just created the database. So I'm creating a table called employees, and it is going to have 3 columns: employee ID, name, and a department. Employee ID is going to be of integer value, name is going to be varchar, and department is going to be varchar again. And each varchar is going to hold up to 100 characters, and the employee ID is integer. At the same time, we have set the auto increment as well. So auto increment is like a surrogate key where you assign a new ID or a unique ID for each of the rows. Okay, it's like an auto generated ID for each of the rows. And we are also letting know the system that employee ID is my primary key. All right, let's see how our table looks like. Select star from employees. So if you see here, we've got a employee ID, name, and department, right? So now I'm trying to insert few values into my table, the employees table, having duplicates as well. So what's happening here? I'm trying to insert values to my employees table, name and department. I'm not giving any employee ID because we have set auto increment, which is going to give an auto generated value for each of my rows. And the values are Alice HR, Bob IT, Alice HR. It's a duplicate, right? We are trying to simulate a duplicate value. We have got Charlie for sales, Bob for IT, Diana for sales, E for IT, and E for IT. So we have got few duplicates in here. I've inserted it. Let's see how our table looks like. As you can see here, we have got Alice HR, Bob IT, Alice HR, it's a duplicate value. Charlie sales, Bob IT, it's a duplicate value again. We have got Diana for sales, E for IT, and E for IT. So we have got nearly three duplicates, right? Alice HR, Bob IT, and Eve IT are the duplicates. This is okay because we know about it, but in larger data sets, you cannot keep a track record of how many duplicates you have got, or you're it's hard for you to know exactly how many duplicates are there. It's not impractical, but what I'm trying to tell in here is, while working in an industry, you have to make sure that your workflow is easier and smoother. So there should be no hard coded jobs, or there is no room for where write down or memorize it. It should be all automated, right? You should know how the code works rather than knowing what the duplicate values are. So make sure you pay attention to this. Okay, we have seen how our table looks like. Now, as a first step, what we have to do, we have to detect the duplicates, and then only in our second step we remove the duplicates. Okay, so what I'm doing is I'm selecting the name, department, and then what does the count function do? So it's going to count the number of rows. It's an aggregate function, so it is going to count based on the name and department after grouping it. So we are just trying to get the rows where the count is greater than 1. So let's see here. So Alice HR is having a count of 2, Bob IT is having a count of 2, Eve IT is having a count of 2, which we already know about, right? So we have seen how it works. We have seen what data we inserted in. So we are very sure about it. And then what I'm doing is a CTE table here, from which I'm taking all the values, assigning a row number, and then I'm deleting it in my original employees table. If employee ID is in this ranked, then we are going to delete it. Let me run the code and let's see how our data looks now. As you can see here, we have got only one record for Alice HR, Bob IT, Charlie sales, Diana sales, Eve IT. So what has happened here? So anything that has more than one count of row number, we have deleted it to our original table. Okay, after extracting it from our temporary table called ranks. So this is how you detect and then remove your duplicates. So to our next question now. I hope this is very clear to you. How do exist and in differ in subqueries? So you all know about subqueries, right? Subqueries is where you write queries within a query. Simple as that. So where you write more than one query within a query, it's a subquery. So there is a difference between exist and in. So what happens when you use exist and what happens while you use in? If you're using exist, it stops at the very first match. Okay, so let's say you're trying to find let's say in a different way. um, okay, let me show it in a simple way. You have 3. Okay, you have to find 3, and my data set is, this is just an example. Okay, what happens if I'm using exist? I'm trying to find what? 3, right? So what happens with exist is that if I'm trying to find 3, right? If the data set is existing, okay, if the element is existing within the data set, it just exits, okay, in the very first instance. So that's what I mean by stops at very first match. So what happens is here, so first it checks for, okay, no, so now it is no. So then it goes to 2, it is no, and then it goes to 3. All right, so when it finds this, it's going to be yes, and it stops. Simple as that. Okay, This is how exist work. And exist is more efficient, and exist is not affected by null values either. So there are chances of having null values in a data set, and even if there are null values, exist is not bothered because it stops at the very first match. And because it is not affected by null values and it stops at the first match, it is more efficient. In other words, it is faster on the larger tables. What do I mean by it's faster on larger tables? Let's consider a scenario. Okay, this is just, I've drawn 5 elements in a list, but in a real production environment there are chances that you might have almost like 1 GB of data, or 2 GB of tables. And when you run joins and those kind of stuff, your table is going to be massive, right? And if you're going to find certain elements or certain results out from your table, once it exists, it cuts off your code, so you're saving your performance. And because it stops, you're not doing unwanted full table scan, and hence it's efficient, right? But yeah, we will talk about in later, but this is what's happening. So it goes for the first value. No, 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 it's not there. Then it goes for 2. No, no, this is not the value I'm looking for. Now it's 3. It stops. So it's very efficient, and hence it is faster on larger tables as well, especially in larger tables. But talking about in, what happens is it checks for all values. What do I mean by all values? Let's take our same scenario. I have a data set here and I have to find 3. What happens is, okay, first it goes for 1. It says, no, this is not what we're looking for. 2, no, it's not what we're looking for. 3, no, this is not. Yes, this is what we're looking for. But I'm not going to stop, but I'm still going to look everything. Okay, not this value. 5, no. And once after that, it stops. So this is very inefficient, right? Because all we wanted is just 3, but it doesn't stop there. And then this is an unwanted work. So what happens in is it checks for all values to compare, and then also while using in, it loads all the results into your memory as well. And then it is slower with larger data sets. The reason being, as I said earlier, excess cutoffs immediately when you find certain results. But in is going to run, make sure that it has scanned the full table, and then it is going to end. So hence it is doing an unwanted scan and making our performance inefficient. And because it is inefficient, by scanning the full table, it is slower as well. And in is affected by null values, but whereas in exist, it is not affected by null values. Okay, let's see how this can be implemented in our code for a better understanding. So we have got investors exist. Let me drop the existing table, and now I'm creating a new table which is same almost. Employee ID is going to be integer data type, and this is going to act as a primary key for this table. Then we have got employee name, which is going to be varchar with 50 characters, department ID with integer data type, and then I'm creating a new table called departments. So departments is going to have 2 columns, department ID, which is of integer, and it is going to be a primary key, and then department name of varchar type that can have up to 50 characters. I'm inserting sample data into my both the tables, both the departments and employees table. So let's see how our tables look like. So first, my employees table. You see here Alice department ID 1, Bob department ID 2, Charlie department ID 3, and David with a null value. And in departments, I've got 3 departments, department ID 1 to 3, and the department names are HR, engineering, and sales. So let me run in. So what's happening here? I'm selecting an employee name from employees table, okay, where department ID in. Okay, so I'm going to choose department ID from where? From my departments table, right? So I'm running a subquery here. Select department ID from departments. So I'm going to choose only the employee names from employees table whose department IDs are in departments table. Let's see how before we run, let's see how our code looks like. So I have got department ID 123 for Alice, Bob, and Charlie, and David is not having any. Do we have three departments here? Yes, 123 for departments. And when I run this, what's happening here? It has given me Alice, Bob, and Charlie. Do you know why? Because, okay, few things. Employees table has David, but he hasn't got David ID. And because the department ID for David is null, it is affected, and hence it is not showing up David here. As you see here, this is how in works. But let's see how our access works. I'm selecting employee name from employees table, where I'm using access. And what's happening here, select one from departments D, where D dot department ID is equal to E dot department ID. What do you mean by E and D here? So I've got the table employees, right? So instead of writing employees again and again, so instead of E dot department ID, I can still write employees dot department ID. Okay, but this is very inefficient because you have to write your table name again and again, and it is not recommended in general industry use case. So try to keep it short. So you're using an alias E for employees and D for department. So those are just the aliases name next to the table name. And what is one here? One is like a placeholder. Okay, so instead of retrieving and getting all the data out, this acts as a placeholder and just runs within the memory. So it's not going to give out any results, but rather check it within the system by placing a placeholder here. And what's happening here, I'm trying to match with my D dot department ID. So from my department table to department ID, and employees table that has the department ID for each employees, I'm trying to make a match and I'm checking if it exists. So what's happening in here is I've got Alice, Bob, and Charlie here. But as you can see here, this code is very robust as well, right? And because this is a smaller table, you're not going to find the difference of runtime. But what generally happens is within, it is going to be a lot more inefficient. Let's see, even for the smaller table, you can see how much time it has taken to fetch. So where is the previous code? Okay, see this, it has taken 0.110 seconds, and our exist has taken 0.016. Can you imagine this? Just for a 4 record table, it has made a huge difference. It's 10x faster, right? So this is 110 and this is 0.16. So that's a massive difference if you imagine that for a larger table. So this is a difference between exist and in. You can see how inefficient they are, right? I hope this is very clear to you. And jumping to our next question. Okay, I have got a pro tip for you before we jump to the next. Use access when you're checking the presence, especially with correlated queries. Use in for discrete lists or small static tables. Let's say you're having a correlated subquery. Okay, what is a correlated subquery? Your outer query is going to be still dependent on the inner query, right? So each of your query within a subquery is going to be dependent of the other one. So that's what is a correlated query, subquery. So when you have to just check the presence, go for exist. But you have a discrete list or a small table, then it is okay to go for in. Okay, but even for smaller table, you saw what is the difference it makes, right? So it is giving us almost a 10x difference, right? 0.110 seconds, and exist has given it in 0.016. So go for the efficient one as always, which is our exists. And so our third question, how do you update data using a join? We all know to update a table, but how do you update a table using a join? Okay, update is our keyword here. So what table are you trying to update? So that's what you have to name next. So in here, I'm trying to update my table called employees. I'm using an alias as well, which is E. I'm setting the value now. So to my salary column, what I'm trying to tell is, okay, for my salary, S. Why have I used S here? So if you see here, I've got another table. So in here, I'm using two tables. One is employees table with alias E, and the another table is salary updates with alias S. Okay, simple. So I'm updating the table employee, which is my original table. I'm setting my salary. So this is my salary column. I want to update this column, and this should be equal to something. So that something is S dot new salary. So I'm going to give a new salary as well. So S represents the salary updates table. So I'm using notation to tag to my particular table, which is salary updates in here. So this salary should be equal to the new salary that is from the salary updates table. How am I going to update? So how relevant are they? So they are made relevant based on the employee ID. So employee ID from the employees table and employee ID from salary updates table must be equal. So what I'm trying to tell is they must match. So if they match, what I want you to do is update the salary to the new salary. Okay, that's how we are trying to update our data using the join. All right, so this is very easy. So update the table and setting it. Okay, update. So for in case if you want to remember the syntax, so update is a keyword, then table name, and then set. So I'm setting column name here. So what column do you need to update? So that's what this is, to my new, I mean from is not necessary, but because we are trying to use it based on the join, so this is my another table, and ID matches with the another tables. So this is how you have to work on your update for your joins. So next to our data modeling session, how do you model many to many relationship? What do I mean by many to many relationship? A many to many relationship is when uh, one student can have multiple courses, right? You can enroll yourself to multiple courses, right? Similarly, a course can be taken out by multiple students. I hope you all get it. Okay, let me put it in a different way. You all have been to school. So you're going to have a class teacher, right? So many students can have one class teacher. So you're subject expert. So let's say you have a max class teacher. So all the students, let's say you have 30 students in your class. So these 30 students are related to your one max teacher. And this max teacher can have multiple students at the same time. Okay? Or in other words, many students can have a relationship with many teachers. So you're not just going to be related to one teacher, right? You're going to have multiple teachers. So you're going to have a multiple records in a table, and that will be related to the multiple records. So many students, many teachers, simple as that. Many students, many courses. So many courses can have different students as well, right? So these are the simple scenario for your many to many relationship. Let's see the definition. A many to many relationship means multiple records in one table can relate to multiple records in another one. So many students in a table can be related to many teachers in another table. One student can have multiple books, and multiple books can be, you know, can be owned by multiple students, right? Okay, let's consider the example scenario. A student can enroll to many courses, and a course can have many students. Okay, so how are we going to model a many-to-many relationship? Yes, I have a many-to-many relationship. Yes, I have understood what is a many-to-many relationship. But how am I going to model this? This is a very crucial part for a data engineer because data modeling plays a huge role. So I've got two tables here. Okay, this is a step before we make a many-to-many relationship. Okay, how are we going to model it? But this is our example use case scenario. I've got a students table here with two columns, student ID and name. So student IDs are 1 and 2 with their names Alice and Bob. And then I've got courses table with course ID and course name. 101, 102, the course IDs are. And then course name is SQL Basics and Python. Simple. This is our simple table. So what's happening here is Alice can have multiple courses. Alice can be part of SQL Basics and Python, right? Similarly, Bob can be part of SQL Basics and Python. Okay. Alternatively, Python can be taken by Alice and Bob, and SQL Basics can be learned by Bob and Alice as well. So it's a many-to-many relationship. What we are going to do in here is we have to construct a junction table. What do I mean by junction table? In other words, you're going to bridge the many-to-many relationship. How are we going to do it? By using foreign keys from both the tables. Let's say in our use case, natural key is student ID in here, right? So students table, the natural key is student ID. And for courses, the natural ID is course ID. So what I'm trying to do in here is, so I'm making a new table called student courses. So instead of writing the names again and again, and what I'm doing here is I'm taking the foreign keys from both the table. If you see here, I've got student ID and then course ID. So student ID is a primary key of which table? Student ID, it's a primary key of students table. What I've done here, I've got the student ID as my foreign key in my student courses table. Okay, where does this course ID come from? So this course ID is a foreign key of the table called courses. So I'm creating a junction table which is going to have the foreign keys from both the table. So student ID 1. So one is Alice. Alice is taking courses 101 SQL Basics and Python. And student ID 2. Well, I think it's Bob, right? So Bob, yeah, it's Bob. So Bob is taking Python as well. So 102. And the same course 102 and 102 is being learned by students 1 and 2. So let's see how we have constructed it. So what we have done here is we have created a new table called course student as you have seen above. I've taken the course ID which is an integer, student ID which is an integer again, and I've set the primary keys here to be course ID and student ID for this table. And these are the foreign keys to the course and the student table, right? So that's how you create the junction table to handle your many-to-many relationship. And one more benefit of using a junction table where you have just the integer column type is you're going to save a lot of space. When you have the characters varchar or character limit, even if it is a definite characters, what's happening there is characters are going to hold a lot of space, whereas your integers are going to store your data in a less. I think they own up to 2 bytes, but whereas characters will take up to 8 bytes. So if you consider that for a larger table, that's going to be huge, isn't it? So you're going to save a lot of space with that. And then to our next question, how do you model a slowly changing dimension? So slowly changing dimension in short is called as SCD. So SCD by the name itself, it's very clear. So there is going to be changes to your dimensions, the dimension data or dimension table, however you want to call it. There is going to be changed. And how are you going to model for that? And how? So that's a simple thing, right? So yes, there is going to be changes to your dimension table. How are you going to handle it? So in other words, how are you going to model it? So there are three different scenarios. Okay, but it all depends on your business use case. As a data engineer, you must know what your business requires. You might be a pro data engineer, but if you couldn't contribute to your business, you're of no use, right? Because you have to generate revenue for your business, you have to generate a value to your business. So it all depends on your business use case. What do they want to do with the slowly changing dimension or the changing dimension tables? There are three different ways you can model it. I mean, there are, I think, six types, but most commonly used are these kind of three: type 1, type 2, type 3. It's easily named. The type 1 is where you just overwrite your old data, so you don't hold any history for your data. In type 2, what you try to do is, always whenever there is a change, you try to create it in a new row, and for your existing row you just give a version number or you assign a timestamp. In type 3, you just add a new column for your previous value, and then you will have a new column that is going to have your current value. So basically a partial history. Okay, let me give it in a scenario so that it is better for you to understand. Let's say you have a customer Franklin for your business. Okay, what's happening is he has given a new number. Okay, he has been part of this shop, he's just coming today, and he's giving his phone number to be 111 111. That is his phone number. And tomorrow Franklin is coming and telling, okay, no, I need to update my phone number, and today my phone number is 222 222. So what's going to happen? So in type 1, what happens is, you completely erase my first record, that is 111 111, and you just put in the new value, that is 222 222. So you're not going to have any old history of my previous number. But in type 2, what happens is, let's say the same scenario, I'm coming up with new phone number 222 222. What happens in this scenario is that, instead of deleting or instead of overwriting my data, what you do is, you store my new value in a separate row. So you're going to create a new row with the version and timestamp. So how do you assign version and timestamp? You consider the previous timestamp and version. So for your previous data, what you do is, you try to assign a version number and a timestamp. You compare it with the new one that is being updated at the moment, and your new update becomes the version 2, and it gets the current timestamp. But for the previous one, it gets the version number 1 and the timestamp from when it was in existence and from when is the last existence date, okay, from when a new update was got. So that's how you store your type 2. And in type 3, what happens is, let's say the same scenario but with an extra change. So Franklin has already changed his number once, and now he is coming up with the another change, saying that, no, no, I have got a new number and it's 333 333. So what happens is, you're not going to have my first or the very first number, which is 111 111. So that data is going to be erased, but you're going to have my previous value, which is 222 222, and my current value, which is 333 and 333. So you're going to have a partial history. So based on that, you design your uh, slowly changing dimensions for your business use case. And to our third question, what's the difference between a fact and a dimensional table or a data? So fact table, it is always a quantitative data. What do I mean by quantitative data? It's more or less to do with numerical based data. Okay, these values are measurable and they are quantitative. But talking about dimensions, those are descriptive data. Okay, so it's not going to be numerical. Even if it is numerical, it is not exactly quantitative as fact table. So fact table is going to be always quantitative, and dimensional is usually of descriptive data. Okay, you're going to define the attributes for your facts. So example, in fact table you might have a sales amount, you might have the transaction amount, you might have the order count. So these are numbers, right? But in dimension table, because you add a description or you try to add attributes to your fact table, so for these sales amount, you might have a dimension as, okay, we have got a sales amount, but what are the products? What is the name of the product? Okay, who has ordered it? What is the detail of the customer? What is the customer name? What is his address? So these are going to be the dimensions. So these are attributes or characteristics. So fact table goes to a modularity of transaction level, but dimension table deals with the referential data. And the keys, how is the keys placed in fact table and dimension table? In fact table, you have the foreign keys to your dimension tables. Okay, dimension tables will have the descriptive attributes, right? So these are going to have your primary keys, and from these primary keys you're going to derive foreign keys for your dimension table. And the main usages for aggregations, because I've said to you, right, we are going to have quantitative data or a lot of numerical data. In that case you're going to deal with a lot of aggregations, but in dimension you're going to have a lot of filtering and grouping, because you're going to deal with categorical and alphabetical or character or referential based data. Jumping to our third part, the big data technologies. Can you explain how a Kafka works? So Kafka is a distributed event streaming platform. Okay, so what do I mean by event streaming platform? So you're going to have a real time data that is going to be streamed. What do I mean by stream? So it is going to be fetched, it is going to be published, and then it is going to be processed in real time. Okay, so that's what you use Kafka for. It's a event streaming, so it's a real time streaming service, simple. Okay, and it supports with the high throughput and fault tolerant real time streaming. Why it can provide high throughput? Because it is distributed. How it is being fault tolerant? Because they are distributed, and make sure that your system is always reliable, it is always up active and not not having a downfall. So it's going to be a fault tolerant real time streaming service. So that is a key word that you need to know before we jump to knowing how a Kafka works. So there is a keyword called message. What do I mean by a message in Kafka? In context to Kafka, it is a unit of data sent by a producer which is going to have a key value and a metadata. A metadata can be of any information like timestamp. Okay, so talking about the working of a Kafka, you have got producers, you have got brokers, and you've got producers, you have got brokers, and then you've got a consumer. What happens in nutshell is producers will send messages to topics. What do I mean by topics? Okay, so Kafka topics is what you call in general. So there is going to be topics. To these topics the consumers subscribe. So when they subscribe, so when they subscribe, those Kafka topics, when they publish a message to these broker, these can be accessed by the consumer. Okay, so Kafka producers, they send messages to these Kafka topics, and these topics are stored into partitions. So if you see, there is a broker, and within broker you're having partitions, right? So the message, okay, in simple, okay, let's talk about the diagram here. You have a producer here, and you're producing message here, message for A0 and message for A1. It is going to the broker, and what's happening here, to the same topic. Okay, topic A, topic A, topic A, topic A. But what's happening here? It is being leveraged within two partitions within a broker. So partition 0, partition 1. And here, those get replicated as well. So this is what I mean by fault tolerant system. So the brokers are replicating the data within the brokers, and these topics are subscribed by the consumer, who then gets to access these messages. Okay, in short, by definitions, producers send message to topics, and topics are split into partitions as you see here. These brokers will store the message per partition as you see here again, partition 0 and 1, and they handle the message. What do I mean by handle the message? They store, they hold the messages. So that's what I mean by handling the message. And those consumers that they have subscribed to the topic, they get to pull and read these messages from the brokers. So that's how your Kafka works. What is the role of a HBase in a Hadoop ecosystem? So HBase is a HBase is a NoSQL database that runs on top of a HDFS, and they also provide real-time read-write access to large data sets. So this is by definition. But in short, what is a HBase? HBase is a NoSQL database. Okay, that's all I think primarily you need to remember. And because we were talking about the Hadoop ecosystem, HBase runs on top of this HDFS. What is HDFS? It is a Hadoop, which is a highly distributed file system. So they provide real-time read and write access to your data sets. Okay, and here are the key features. In relational database management systems, you store the data in an row-orientated way, right? So for each row, you talk about rows in RDBMS, right? So for each row, you get to store certain values. You have fields within. So you store the values in a row-oriented order. But in HBase, because it is a NoSQL database, you store the data in a column orientation. These are built for sparse and wide tables. Okay, what do I mean by wide tables? So you're going to have millions of rows and columns, and sometimes, and especially to do with NoSQL, you're not going to have all the rows filled with certain data, right? So there are chances that you will have only certain values filled in. So few rows could be empty, but it doesn't matter because it is built for a NoSQL ecosystem. And they also provide us with low latency, and they also provide us with faster read and write. Because it is a NoSQL database, they provide us with low latency because there is no constraints or checks as much as in relational database management system. Because let's say you have set some constraints and your data has to fulfill it, right? But in NoSQL, you don't have that kind of constraint, and therefore your data can be accessed with low latency, and they also provide us with efficient read and write. And then here are a few use cases where you use this. So for instance, for a time series data, for your real-time analytics, for storing logs or IoT events, and for your lookup style queries at scale, you can use HBase. Time series data, you're going to get frequent often, right? Real-time analytics, because they provide us with low latency and they provide us with better efficient read and write. And to store sensor logs or IoT events, because in IoT data, you cannot rely that they are going to maintain a structure. It could be, unstructured at times. They could be semi-structured. In that case, NoSQL database comes into play, and in NoSQL database, HBase plays a prominent role because it runs on top of HDFS. And they also provide, as they provide real-time access to the larger data sets, you get to have real-time analytics as well. So this is the role of a HBase in an Hadoop ecosystem. And then to our final part of the day, the ETL. What are the stages of ETL? ETL stands for extract, transform, and load. So what do I mean by extract, transform, and load? So if you try to understand based on the words, so that's a general way I would always recommend to all my students. Whenever you have a word, try to understand the meaning from the word. So instead of trying to remember something hard, you're trying to extract, you're transforming it and loading it. So as a data engineer, talking in those contexts, what are you trying to extract? You're extracting a data. Where are you extracting it from? From a source. A source can be anything. It can be a database, it can be a file system, and it can be an API. So these are our sources. And once you extract, you want to transform it. How do you transform it? So talking about transformation, I might clean. So what do I mean by clean? I might try to remove the duplicates. I might try to remove the null values. I might try to remove the or handle the missing values. I might try to run a join. I might try to filter my data. I might try to work on my format of the data. What do I mean by format of the data? For instance, your date. Okay, if you're in US, you might have a different format of writing a date. You might write it in a way like month, date, and your year. But let's say you're working in a region like UK or India, and you're going to follow a time system in a format that is of date, month, and your year. So in that case, you have to handle the data. You have to format the data in relevance to your local region. So that's how you format it. So that's the process of a transformation. Once you transform it, what do you want to do? You want to load it. What do I mean by load? I'm inserting my data to a target. I'm pushing my data to a target. The data that I have pulled from the extract, I've processed it, and now I want to load it or dump it into a target. And a target can be anything. It can be again a file system, it can be database, it can be data lake, it can be of any sort, but you're loading that to a target. So these are the stages of a ETL. What are the common ETL tools? This is for your general knowledge. So the common tools within ETL are, talking about open source, you have Apache Nifi, you have Talent, and you have Airflow. Okay, so these are the different source you have for your ETL job. Okay, and these are the open source tools that you have. But talking about enterprise editions, you have Informatica, you have SSIS, you have AWS Glue, you have ADF, you have those kind of sorts. And talking about only the cloud native ETL tools, you have Fivetran, you have Stitch, and DBT. There are still more plenty of tools, but keep it limited because this is just for your broader general knowledge. And if you have to master it, you have to become expert in it, you have to at least spend 2 months on each, right, to get better if you have to become an expert. So these are the ways. I mean, there are plenty of tools, but don't waste on all those. Try to choose your niche and focus on that, and then try to focus on that and learn as much as and become an expert in it so that you become a data engineer. They say that, right? A master of in everything is a jack of all trades is master of nothing, right? So you don't want to be a joker of everything, right? But rather be a pro or a king or a master at one skill. So though there are multiple options and tools available, try to focus on one tool. Okay, if you ask in my option, go for a cloud based, go for AWS Glue or a ADF, which is an Azure Data Factory. Maybe prominently nowadays, Databricks and Snowflake is booming up. So try to focus on those ETL tools first, then you can jump to use all these kind of tools. So a final question of the day: what is incremental load and how is it implemented? What do I mean by incremental load? So let's say you have done a bulk load in the sense a historical load. You have 1 GB of size of data for your company. You have loaded that into your warehouse now. You're all done, perfect. And now, let's say today's date is 14th of July, and tomorrow you are getting a new data for the 15th of July in your database. How are you going to handle it? So, this is what you call as an incremental data. Your new load or your new data or the new set or a new batch of data that has been into your system once you have finished processing all your historical data sets. So by definition, historical load only fetches new or changed data since the last ETL run, instead of reloading the entire data set. You have already processed your historical data, right? And there is no need for you to process your historical data again and again, because it is very inefficient. It is an unnecessary process. So in incremental load, you only fetch the recent or current or the new changes of data that has been put into your database. So how do you implement it? There are a variety of ways. We will see those in short. So first method that you have is timestamps. So you can choose an timestamp column within your, you can set a timestamp column within your existing table. So each time your data comes in, you can put in something like at what time the data was updated. You can compare it with your last runtime. So let's say you have a new table that's coming up at 15th of July. If you compare it with your last runtime, that was 14th of July, so your updated at is greater, right? So this is your new date, and last runtime is yesterday's one. So if you compare, you just process only the data that is after the date of last runtime. So you could process the incremental load based on timestamps. Then the other strategy is changing the flags. What do I mean by changing the flags? You can use certain values. You could use booleans like true or false, or you can set categorical values like new, old, and these kind of flags. So that's what I mean by flag. Flag is nothing but you use certain words or certain uh, keywords within the database to track down what is the last change that has happened in your table. So for instance, you can set a column name is updated. Okay, is updated is my column. If it is updated and it is set as true, then don't process it because it has been updated, right? Or if the status says new data, then you process it because my database tracks down this flag as a new one. Just process this incremental data, and once you load it, change the status to old. Simple as that. Then you can use watermark or change data capture. So change data capture is simple by the definition. You are capturing the data which has only changed. So you're changing only the data. You're capturing only the data that has changed. So that's what is mean by CDC or change data capture. So you are going to capture the changes for your logs or from your replication. So that's how you implement CDC. The final method is triggers, and then with the triggers you also use audit table in uh, in complementary to this. So the triggers will log changes into your new audit table. What do I mean by that? So you're going to have your original table, and then you're going to have an audit table. So whenever the new data comes in, a trigger is going to be set on your original table, and you're going to audit. So audit is like, it can include information like when the data was in, has the data been processed, how much, I mean, what is the total count of the data, what is the checksum value of the data. So once you process that, and then you store those in the audit table, and your incremental load tracks down the data from the audit table, compares it, and only process the table or the data after checking with the audit table, right? So you're going to have the original table, it is going to be triggered, and then these triggers are going to store the value to the audit table, and this audit table are compared for your incremental load. And once it is compared, and then you're going to load your data, or you're going to do an incremental load. So that is all for today. I hope you all learned a lot of stuff today. uh, a new concept, fresh concept. It could be new to you, but do not worry. If you have at least grabbed 60% of what I've taught you now, I'll be more than glad. So just go for a revision, read through the material I've provided. So try to take a screenshot, try to remember them. So it'll be very easy for you. All right. So that is all for today. So hope you all enjoyed it. Uh, if you haven't liked the content, do like the video, If you have any questions, do drop it in the comment, or if you find this video useful, do drop some appreciation. It'll help us and to stay encouraged. And if you're new to this channel, do subscribe to our channel and do click the bell button as well, so that you don't miss on the updates. And if you are of a regional speaker of different languages like Tamil and Telugu, do follow our Data Value Telugu and Tamil channels as well. And we provide you with variety of contents like ethical hacking, Java development, Python developer, SQL developer, data engineering, data analytics, data science, agentic AIs. We have multiple streams being you know published every day. So make sure you learn all those, and we are doing it with a passion for you all to ace in your jobs. So do follow us, do check our website as well. Feel free to call to our institute, they'll get back to you. And good luck with your learning as well. And before we end, we have our headquarters USA, in UK, and we have 4 centers within India as well. We are growing up faster in India. We are trying to establish new headquarters in Chennai as well. So we are growing massively. So do check up on us, and I hope this video is very beneficial to you. So good luck with you all. You enjoy the rest of the day. Thank you so much for joining. Until then, this is Franklin signing off. Bye bye. Take care.